Friends, yesterday we have discussed about the two parametric techniques, that is independent t-test and dependent t-test. Yesterday we started from different statistical techniques and we divided these techniques into two parts, parametric and non-parametric. We further classified two techniques, this parametric technique, into two subparts, that is comparative and relationship. In relation to the comparative statistics, comparative techniques, we have discussed about the smallest type of comparison, means the comparison between two groups. Today we will discuss about a technique used to compare more than two groups. After that we will discuss about covariate. By taking covariate, we will discuss about the relationship statistics. We know that the technique which is used to compare two groups is known as a t-test. In other words, we can say that the technique which is used to find out the significant difference between the means of two groups is known as t-test. And there are three different types of t-tests. Independent t-test. We have discussed in detail about the application of independent t-test. Next one is dependent t-test. We have also discussed about the concept of this also, and one sample t-test. Again I repeat, independent t-test is used to compare two independent groups. Dependent t-test is used to compare two different observations of the same group. One sample t-test is used to compare a group with a fixed value. It means independent t-test is used to conduct survey studies, dependent t-test is used to conduct experiments, and one sample t-test is also used to compare to conduct survey studies. Today we will discuss in detail about the application of a new technique that is known as one-way analysis of variance. We will discuss about one-way analysis of variance. This technique, this one-way analysis of variance, one-way Anova, is also known by different names. Another name is simple Anova. One more name is Anova single factor. So this technique is known by three different names: one-way analysis of variance, simple analysis of variance, and analysis of variance single factor, Anova single factor. I will start from interaction. Any of you, please tell me, anyone from you, please tell me what was the hypothetical title for independent t-test. What was our yesterday's hypothetical title for independent t-test?
Comparison of hemoglobin levels between male and female.
Comparison of hemoglobin between males and females. Madam, we were having two groups. We conducted the study on 60 subjects and divided these subjects into two different groups, males and females, consisting of 30 subjects each. And our objective was to find out the significant difference between the hemoglobin of males and females. That was our objective. In case of one-way Anova, in layman's language, I am not talking in language of statistics. In layman's language, we can say that one-way analysis of variance is an extension of independent t-test. You may note down. This is the main sentence that clarifies the meaning of this one-way Anova. One-way Anova is an extension of independent t-test. Then the question arises, what is independent t-test? Independent t-test is used to compare two independent groups. Since one-way Anova is an extension, we can say that one-way Anova is used to compare more than two groups. Maybe 3, maybe 4, maybe 5, maybe 6, maybe 7, and of n numbers. Now, in the words of statistics, we can say that one-way Anova is a statistical technique used to find out the significant difference among the means of more than two samples, more than two groups. Let's formulate a new title. for one-way analysis of variance. New title is Comparison of Hemoglobin between arts, commerce, and science students. We have taken three groups. Suppose art group students possesses the higher level of this hemoglobin, or commerce students or science students. In independent test, we were having two groups, that is male and female. But in this one way, instead of two groups, we have three different groups. Now, our today's hypothetical title for one-way ANOVA is Comparison of Hemoglobin between Arts, Commerce, and Science students. Madam, on how many students you want to conduct this study? You may assume. On how many subjects you want to conduct this study?
Sir, 20 each in each group.
20 in each group. It means total number of subjects will be 60. Is it okay?
Yes, sir.
You want to conduct. Now, madam, your voice is clear. Please interact with me. The previous voice was not clear. Our hypothetical title is Comparison of Hemoglobin among Arts, Commerce, and Science students. As you have said, you want to conduct a study by taking 60 subjects, 20 in each group, 20 from Arts group, 20 from Commerce group, and 20 from Science group. What will be our objective? You may write down the objective also. The objective of the study is to find out the significant difference among the Arts, Commerce, and Science students in relation to hemoglobin. What will be the hypothesis? You may formulate any type of hypothesis. Suppose we formulated that null hypothesis. It is hypothesized that there shall not be any significant difference among the Arts, Commerce, and Science students in relation to hemoglobin. You may use your own words. And we are going to apply one-way ANOVA. Now, first we will discuss about the analysis of this technique by using this Microsoft Excel. I am going to enter 60 scores in Microsoft Excel spreadsheet. Please open your Microsoft Excel spreadsheet. You may do analysis, you may perform analysis simultaneously with me. Please tell me, what is the name of the first group?
Arts group.
Arts. Please write down. Next group?
Commerce group.
Commerce. Write down Commerce. And third one is Science. And I am going to enter the scores after the collection of data in Arts group. Since we are going to conduct this study by taking 60 subjects, 20 in each group, these are the 20 scores of hemoglobin that belongs to Arts group. Is it okay? How many scores are there?
20 scores, sir.
20. Now I am going to enter the score of the hemoglobin of Commerce students, 20 students. Since we are going to, please keep in your mind, same as independent t-test, this technique can be applied with equal sample size as well as unequal sample size. We are conducting this study by taking equal sample size, means 20 subjects in each group. But you may take unequal sample size also, 20 in Arts, 25 in Commerce, 30 in Science. Again, I repeat, this technique can be applied with equal sample size as well as in unequal sample size. But we are conducting this study by taking equal sample size, that is 20 subjects in each group. Now I am going to enter the scores of the Commerce students. We have 20 subjects in this group also. I entered all the 20 scores belongs to that commerce group. In the science group also, we have 20 subjects. Now I am going to enter the scores of commerce group. We have total 60 scores. Now the data entry is complete. We are analyzing by using Microsoft Excel. We are discussing about a one-way analysis of variance used to compare more than two groups, and in our hypothetical example, we have 3 different groups. Now write down the commands and perform simultaneously with my commands. Where is my arrow?
Data.
Data, click on data. But see, this icon is not visible. I am opening again after saving this. You may find this type of error. Now I am going to open with Excel. Again, I am going to click on data. Now where is my arrow?
Data analysis.
Click on data analysis. And one-way Anova is the first technique in this list. First technique, this is known by the name Anova single factor. Select this Anova single factor. Select this Anova single factor. Is it okay?
Yes, sir.
Click on OK. We have only one input range. In front of the input range, click on this arrow and select all the scores including this heading. Again, click on the same arrow. Then opt for this labels in the first row. Since we have given the title, that is arts, commerce and science, in the first row, and click on OK. The results will be in front of you. See the results. Madam, how many counts? Counts means subjects. How many counts we are having in this arts group?
20, sir.
20 in arts, 20 in commerce, 20 in science. And average means the mean value, the point estimate, the mean value. What is the mean value for arts group?
7.95.
And for commerce?
7.85.
And for science group, 8. Is it okay? And this is the value of the variance. We have to take decision. What was our objective? Our objective was to compare arts, commerce and science students in hemoglobin, in relation to hemoglobin. From the observed average, the calculated mean is 7.95, 7.85 and 8. It seems there is a difference. After seeing the average, it is seen that the science students possesses the higher level of hemoglobin. Is it okay? Agree?
Yes, sir.
But this is a visual difference. Our objective is to find out the significant difference. And to find out the significant difference, we have to apply this Anova. We applied Anova. And what was the final answer by t-test? Madam, what was the final answer by t-test? T ratio, T value. Is it okay?
Yes, sir.
And in one-way Anova, instead of T value, we will get the F value, F ratio. We can say F value or F ratio. Is it okay?
Okay, sir.
What our obtained F ratio is? F value is?
Sir, what is
0.18.
Yes, madam, please ask.
What is F, sir? Just a
What
T
is-
test. Hanji.
What is?
F.
F means F value or F ratio.
Hmm.
From T test, we calculated T value or T test, T
Yes.
value or T ratio. Is it okay?
Yes.
This is F value. What is our F value? Or we can say that what is our F ratio?
0.87.
8.
And this, what do you mean by P value? P value means the significance value. We have discussed yesterday. P value means the significant value. Is it okay?
Yes, sir.
In this case also, if this value is less than 0.05, in that case we can say that yes, there is a significant difference. But this value is very high than 0.05. The P value, the obtained P value is 0.082. But for significant difference, we require less than 0.05. You can write, since the P value is higher than the 0.05, that is 0.82968. So there is no significant difference, or no significant difference is observed among the hemoglobin of arts, commerce, and science students. All the three groups, that is arts, commerce, and science, all the students possesses the same level of hemoglobin. Is it okay?
Yes, sir. What do we have to look at for in the F value? Is there any significance with respect to F value?
Yes, please recall my statement. Recall my yesterday's statement. We can conclude in two different ways. One way is if the significance value is less than 0.05, it means there is significant difference. Another is we can compare this obtained value F value with this calculated F critical. Calculated is known as critical. If this F value is higher than the critical value, F critical value, it means significant difference is there. If you want to compare, madam, if our obtained F value is 0.18732 and our tabulated value means F critical value, that is 3.15. This 0.87 is less than 3.15. So it is concluded that there is no significant difference among three groups. Is it okay?
Yes, sir.
You may opt any one method, and this if we compare this obtained value with the tabulated or critical value, this is an old method, but nowadays in the refereed journals, indexed in PubMed, indexed in Web of Science, indexed in Scopus, you will not find this critical value. On the basis of P value, we take decisions, we conclude, we express findings of the study. Is it okay?
Yes, sir.
Are you comfortable with my speed?
Yes, sir.
Okay. Now we will do the same by using SPSS also. Please remember these scores. Average of arts is 7.95, commerce 7.85 and 8, and the F value is 0.187 and the P value is 0.82968. Now I am going to copy these scores, 60 scores, and I am going to paste all these scores in SPSS. I am going to paste these scores in SPSS. Now we are going to analyze by using SPSS, same technique, that is one-way analysis of variance. We know that this technique is known by three different names: one-way Anova, Anova single factor, and simple Anova. I pasted all the 60 scores in three different columns. First column belongs to art, second commerce, and third one is science. Madam, my question is, during analysis of independent t-test, in how many columns you entered all the scores?
In one single column, sir.
It means 30 plus 30. Is it okay?
Yes, sir.
Since this technique, in layman's language, we have discussed that since this technique is an extension of independent t-test, so it's clear we have to enter all 60 scores in the single column. First 24 arts, next 24 commerce, next 24 science. Now I am going to enter all the scores in a single column. Now next 20 scores are for commerce and the last 20 scores are for science group. Is it okay?
Yes, sir.
First 20 scores belongs to
Arts groups.
arts, next commerce, next science. So in the same way, same as independent test that we have discussed yesterday, we have to give the value for each group. Suppose I'm going to give the value 1. 1 stands for
Arts groups, sir.
arts group. So enter the value 1 in front of the first 20 scores, since first 20 scores belongs to arts group. And the next 20 scores belongs to commerce, we know that. And I am going to give the value 2 for commerce. Enter the value 2 in front of next 20 scores. 2 stands for commerce. And 3 stands for science. 3 stands for science. Okay. Now click on variable view. In the first column, we have the scores. We have all 60 scores belongs to 3 groups. Hemoglobin scores. Write down hemoglobin. And in the second column, we have 3 groups. You may write group, you may write subject also, since we have 3 subjects, arts, commerce, science, or we have 3 groups. So I am going to enter the word, the name of the variable, that is group. Madam, how many groups we have?
3 groups.
3. So in front of the group, same as independent t-test, click on in the row of values. Is it okay?
Yes, sir.
Click on this and enter 1 in the value, and we have given the label
1 for arts group.
arts. Write down art and add, and write down 2. Label, our label for 2 is
Commerce group, sir.
commerce. Add this, and third one is science. And click on add. Click on OK. Now the data entry is now complete in SPSS. Now we have to give the command for analysis. Where is my arrow cursor?
Analyze.
Analyze. Click on analyze. Now where is my cursor arrow?
Compare means.
Compare means. Now
One-way Anova.
click on one-way Anova. Bring hemoglobin independent variable and group in the factor. Please keep in your mind. Bring hemoglobin independent list and group in the factor. Is it okay?
Yes, sir.
Click on options and select this descriptive statistics. Descriptive. Continue. Click on OK. The result will be in front of you. See for this mean value, in that we were using the terminology average in Excel, but here we are using the terminology
Mean.
Yes. Our mean for arts group is 7.95, 7.85, and 8. And this is the total combined mean also. We have the combined mean of all the 3 groups. And we have standard deviations also. We have the minimum score also, maximum score also. The output of SPSS is more meaningful in nature. And we have confidence interval for mean also. And we have this ANOVA. What is our F value?
0.187.
Is it same or is there any difference?
It's the same as in Excel,
And
sir.
what's the significance value?
0.8.
0.83. Is it same or is there any difference?
It was 1 second, sir. P value was 0.9 in Excel. 0.94. Oh, sorry. It was the same. I'm sorry, sir.
It's the same. Okay.
Yeah.
Now, since the significance value is is greater than 0.83, so there is no significant difference between the hemoglobin of arts, commerce, and science student. Is it okay?
Yes, sir.
Okay. Now, please. Now we will discuss about the remaining part of this. Please try to understand my point. We are discussing about a one-way analysis of variance. Madam, how many groups we have?
3 groups.
3. Now, please write down. If insignificant difference exists, the study ends. Again, I repeat. If the insignificant difference exists, the study ends. In this hypothetical example, there is an insignificant difference. There is no significant difference. So this study ends, and the final finding will be there is no difference between the hemoglobin of arts, commerce, and science students. But dear participants, if significant difference exists, we have to extend the study. Again, I repeat. If the significant difference exists, we have to extend the study. Madam, how many groups we have?
3 groups, sir.
3 groups. Suppose if significant difference exists, madam, there will be possibility that difference may exist between arts, commerce, and no difference may exist between commerce and science. It's possible.
Yes, sir.
It means if the significant difference exists, we have to compare paired means. How many mean we have?
We have 3 means.
3 mean, arts, commerce, science. And in this hypothetical example, where we have 3 groups, where we have 3 means, how many pairs we have? We have 3 pairs, arts versus commerce, arts versus science, and science versus commerce. Is it okay?
Yes, sir.
It means if the significant difference exists, we have to compare paired means. We have to extend the study. Then the question arises, how we will compare paired means? After applying Anova, after applying one-way Anova, if the significant difference exists, we have to extend the study. We have to compare paired means. And to compare paired means, we have to apply post hoc test. We have to apply post hoc test. Is it okay?
Okay, sir.
We have to apply post hoc test. And please try to recall my point. This technique of one-way Anova may be applied in equal sample size or may not be applied in unequal sample size. And in our condition, we applied this technique by taking equal sample size. Is it okay?
Yes, sir.
So there are 2 different types of post hoc tests. If we conduct the study by taking equal sample size, the post hoc test will be different. And if we conduct the study by taking unequal sample size, the post hoc test will be different. The post hoc test in case of equal sample size is known as LSD post hoc test. LSD. LSD stands for least significant difference post hoc test. Least significant difference post hoc test. I am suggesting this. It doesn't mean that we can apply only this. There is a long list, but we have to apply only one test. But it is suggested by the eminent statisticians, if you conduct by taking equal sample size, if you conduct the study by taking equal sample size, it is suggested to apply LSD post hoc test, least significant difference post hoc test. Is it okay?
Yes, sir.
If we conduct the study by taking unequal sample size and we want to compare paired means, in that case, we have to apply SPSS post hoc test. SPSS. I will show you the spelling. SPSS post hoc test. So, madam, my question is, in our today's example, which post hoc test will be applied?
LSD.
LSD. Madam, Gurmanjeet ji,
Yes.
madam, why we are going to apply LSD?
Because equal size 20, 20, 20.
Yes, since we conducted the study by taking equal sample size. Is it okay?
Yes, sir.
Now, how to apply this post hoc test? We have to extend this study. See how to apply this post hoc test. Without saving, I am closing this. See, where is my arrow?
Analyze.
Analyze, click on analyze. Now, please tell me.
Compare means
Compare means now.
it is on one-way Anova, but
Click. Yes, click. Okay, one way Anova. See. Now, where is my arrow now?
post hoc.
Click on post hoc. You will find a long list. LSD, Bonferroni, SIDAC, SCAFES, SNK, Tukey's SB, Duncan. There is a long list. And
Yes.
since we are going to, we have conducted the study by equal sample size, see, we have to opt this LSD. Otherwise, see on the serial number 4, SCAFES, SCHEFFE, SCAFES.
Yes,
This
sir.
SCAFES post test is applied in case of
Unequal sample size.
unequal sample size. Okay.
Yes, sir.
Click on continue, click on OK. See the post hoc test. Multiple comparisons. Multiple comparison means, madam, how many pairs we have?
So we have 3 pairs.
3 pairs. See my arrow. Arts versus commerce. No significance. Arts versus science. No significance. Commerce versus arts. Instead of 3 pairs, we have 6 pairs here.
Yes, sir.
We should not be confused. See here, arts versus commerce or commerce versus arts, the answers will be same. या तो arts को commerce से compare करो या commerce को arts से compare करो, the answer will be same. Is it okay?
Yes, sir.
So this is a lacuna of the software. Instead of 3 pairs, the output has this 6 pairs. But we know that first pair is art versus commerce, second pair is arts versus science, and third pair is commerce versus science. Since there is no significant difference was found, since in this paired means also no significant difference is found among all pairs. Is it okay?
Yes, sir.
So we compared means. Now I am going to ask a few questions. Since I am going to explain the complete utility of this one-way Anova, we have discussed up to post hoc test. Madam, please, any participant. We applied one-way Anova.
Yes, sir.
Conducted a study by taking equal sample size, 20, 20, 20, arts, commerce, science.
Yes, sir.
And we seen if significant difference exists?
No, sir.
If significant difference exists,
Then we apply post hoc.
no, if significant difference exists, we have to apply post
Study
hoc.
ends.
Yes, in equal sample size, LSD, in unequal sample size.
SCAF is post hoc test.
But before applying, please try to get my point. Before applying this one-way ANOVA, we have to test the assumption the data should be normally distributed. Is it okay? We have discussed yesterday. The data
Yes.
should be normally
Distributed.
distributed. If the data is normally distributed, we have to apply one-way ANOVA. If the data is non-normally distributed, in that case, we have to apply parallel non-parametric technique of this one-way ANOVA. The function will be same. And the parallel non-parametric technique of one-way ANOVA is known as Kroskal-Wallis test. Kroskal-Wallis test. Is it okay?
Okay, sir.
It means today we are discussing about the use of two different techniques. One is ANOVA and one is Kroskal-Wallis.
Yes. Hmm.
ANOVA belongs to parametric and
Hmm.
Kroskal-Wallis test belongs to
Non-parametric.
non-parametric. And the function of both the techniques is same. Both techniques are used to compare more than two groups. Both are used to find out the significant difference among the means of more than two samples.
Hmm.
Our title is same.
Hmm.
Comparison of hemoglobin between arts, commerce and science student. Title is same. But assumption is not fulfilled. Assumption is not fulfilled means data is non-normal. In that case, we have to apply Kroskal-Wallis test. Is it okay? If you
Yes.
have any doubt, if any participant have any doubt, you may ask now. Otherwise, it will not be possible to grasp.
Sir, is it possible to do post hoc test in Excel also?
Yes, it's a good question. Yes, I forgot to reply. There is no option of post hoc test in Excel. If the significant difference exists, we depend on other softwares. We depend on SPSS or Minitab or other softwares. Dr. Saab, is it clear?
Yes, sir.
Any other question? No. Now we are going to analyze by using parallel non-parametric technique named
Kroskal-Wallis test.
Kroskal-Wallis test. K-R-A-U-S-K-A-L. Kroskal-Wallis test. Kroskal-Wallis test. You may write down. The data entry will be same as one-way ANOVA. The data entry will be same as one-way. There will be no difference between the data entry of one-way ANOVA and Kroskal-Wallis test. Already we entered all the 60 scores in the single column. We have given the values 1, 2, 3 for arts, commerce and science respectively, and we have given the labels arts for 1, commerce for 2, science for 3. The data entry will be same. We are going to apply the parallel non-parametric technique of one-way ANOVA, Kroskal-Wallis test. Click on analyze. Now please tell me, where is my arrow?
Non-parametric test.
Yes. And now go to this one. This is legacy dialogues. Is it okay?
Okay, sir.
Now go to this K independent sample. Here K means N of numbers. K means N numbers, more than 2. Is it okay?
Yes, sir.
Click on this K independent sample. Which technique we require? Madam,
Crystal.
yes, see. Is there any technique named Kroskal-Wallis?
Kroskal-Wallis H
Ah,
test. Where the arrow is there?
yes, this technique is there. Already selected, already opted.
Hmm.
And bring this hemoglobin in the test variable and bring this group in the grouping variable
Variable.
and define the groups. Define the groups means our minimum value is 1 and include 2 also and maximum up to 3.
3.
1, 2, 3 include. We are giving the command include 1, 2, 3 values in this analysis and continue. Is it okay?
Yes, sir.
And click on options and opt for descriptives. Is it okay?
Yes, sir.
Click on continue. Click on OK. The result will be in front of you. See the ranks. Hemoglobin, we have 20 art students, 20 commerce students, 25, and mean rank is 30.65, 28.50, and 32.35. And this chi-square for the, that is the output of the chi-square, that is 0.561. And the significance value is? Significance value is?
0.75.
Since this value is higher than,
Uh,
this value is higher than,
no significance.
no significant difference. Is it okay?
Yes, sir.
We analyzed by using both the techniques, that is one-way ANOVA and
Kroskal-Wallis
Kroskal-Wallis.
non-parametric test.
in case of one-way ANOVA, we discussed that if no significant difference exists, the study ends. If the significant difference exists, we have to extend the study. We have to compare paired means, and to compare paired means, we have to apply post-hoc test, and for equal sample size, we have to apply LSD, and for unequal sample size, we have to apply
Scafe's post-hoc
Scafe's
test.
test. Same is applicable here. If no significant difference exists, yes, sir. Yes, sir. Please ask.
It's okay, sir. I don't know.
If insignificant difference exists, the study ends. But if the significant difference exists, we have to apply. We have to compare. Paired means how many pairs we have?
3.
In non-parametric technique, there is no option of post-hoc test, but we have to compare. Paired means, it means we have to apply. Please keep in your mind, we have to apply parallel non-parametric technique of independent t-test. In independent t-test, how many groups we have?
2.
2. It means that can be, madam, that can be considered as a pair. दो समूह, दो ग्रुप है तो पेयर ही तो है वो.
Yes, yes, sir.
Is it okay?
Yes, sir.
It means in case of independent t-test, we compared pair. We compared only one pair. Two groups means one pair. It means we have to apply parallel non-parametric technique of
Independent t-test.
Independent
And
test.
the parallel non-parametric technique of independent t-test is known as MAN, M-A-N-N, Mann-Whitney U-test.
Okay, sir. Okay.
U-test. So please tell me, for my confidence, how many times you have to apply Mann-Whitney U-test in this example?
3 times.
Yes, 3 times. It means we cannot compare together. One by one we have to apply.
Yes, sir.
Now, I am going to analyze. See, go to analyze, go to
Analyze.
analyze, then go to,
Non-parametric test.
then go to,
Legacy dialog.
yani how many columns we have?
Columns 3.
Madam, we have two columns. We are
Okay,
comparing.
yes, yes, we are giving groups, and two groups, and one is
Yes, one by one. Yani we have two groups. Arts versus commerce, arts, science, is it okay? How
Yes,
many
yes.
groups we have?
2.
Two means two independent samples. And which technique will be applied?
Which
Man-Whitney test. See, is there any technique named Man-Whitney test?
Yes, yes, it is there already.
Yes.
Tick there.
Bring this hemoglobin in the test variable and group in the
Grouping variable.
grouping variable and define the groups. We are not supposed to write 3. We are comparing only 1 and 2.
2 groups. Yes.
Is it okay?
Yes, sir.
Continue. Click on, you may
Options.
get the descriptive also. Continue. Click on OK. Now, two groups are compared. Arts versus commerce. Total consisting of 40 subjects, 20 in each group. And the Man-Whitney value is 185.50. And the two-tail test, the significance value is
0.63.
0.673. It means since this value is higher than 0.05, both arts and commerce, both groups possesses the same level of hemoglobin. There is no significant difference between the hemoglobin level of arts and commerce group. Is it okay?
Yes, sir.
Now you can ask questions. After that, I will discuss in detail. If you want to ask any question, ask. Do you want to discuss in depth?
Yes, Dr. Roshnara.
Sir, when you did the Kruskal-Wallis test, there they showed the chi-square value, but they
Yes.
are the same test, right, sir? It's a separate test.
It's not a same test. Here we are comparing two groups. There we compared 3 groups.
Okay. Okay, sir. But the value was written as chi-square. So.
It's not the same. There we compared 3 groups. Here we compared 2 groups.
Okay. Thank you, sir.
Any other question?
That same question, non-parametric test, can they be done in Excel also? Same.
No, there is no facility of non-parametric techniques in Excel. There is no facility. Due to this reason, we are discussing about the analysis in SPSS. Due to this reason. Otherwise, there is no need. If every analysis is possible in Excel, what is the need to analyze by using other softwares?
Yes, sir. Exactly. Thank you.
Now, again, I repeat, please try to get my point. Our title is Comparison of Hemoglobin between Arts, Commerce, and Science students. Then parametric technique to compare is known as one-way Anova, and non-parametric technique is known as Kruskal-Wallis test. We have discussed about an assumption, that is normality. The data fulfill the condition of normality. If the normality condition is fulfilled, we have to apply one-way Anova. Otherwise, we have to apply parallel non-parametric technique, that is called Kruskal-Wallis test. Is it okay?
Yes, sir.
I repeated the same. Now, one addition. The assumption of normality is required for all parametric techniques. but few assumptions are technique specific. One more, only one, not more than one. One additional assumption is required to apply this one-way ANOVA. Please, you will find in the research papers. One additional assumption. We didn't test the additional assumption. We have to test an additional assumption. If this additional assumption is fulfilled, in that case, we can apply one-way ANOVA. Otherwise, we have to apply another technique. Is it clear? Is it clear or not?
So additional assumption means?
Yes. You should ask, sir, what is that additional assumption? Additional assumption is homogeneity of variance. The variance among all three groups should be same. Since we are using we conducted the study on 3 groups. We may conduct on 4. Yani homogeneity of variance means all the 3 groups, all the selected groups should have the same variance. Is it okay?
Okay, sir.
It means we have simultaneously with the assumption of normality, we have to test the assumption of homogeneity of variance also. The question arises, which technique will be applied to test the homogeneity of variance? Which technique will be applied? To test the homogeneity of variance, we have to apply 11A test. Again, I repeat, to test the homogeneity of variance, we have to apply 11A test. How to test the homogeneity of variance? I am going to show you how to test. See, the data entry will be same.
Yes, sir.
Go to analyze, go to compare means, and go to one-way ANOVA, and go to this options. See, where is my this?
Homogeneity of variance test.
If we opt for this homogeneity of variance, we will get the output of 11A test. 11A. You will not find 11A here. We are giving the command to obtain 11A value by opting homogeneity of variance test. Continue, click on OK, see the output, see the value of 11A test or 11A statistics. Is it okay?
Yes, sir.
What is the significance of this 11A?
0.98.
Homogeneity of variance means there should not be any significant difference. This value, please, in case of F value, we discussed that if the value is less than 0.05, it means significant difference is there. In that case, this value should not be less than 0.05. If this value is less than 0.05, it means all the 3 groups are not equal in homogeneity in variance. Is it okay? We require equal variance among 3 groups. It means there should not be any significant difference. For that, this value should be higher than 0.05. Is it okay?
Okay, sir.
It means how many assumptions should be fulfilled to apply one-way ANOVA?
Assumption of normal and additional assumption.
What is additional assumption?
Homogeneity of variance.
Yes. If both the assumptions are fulfilled, please write down this. Point number 1. If both the assumptions are fulfilled, condition number 1. If both the assumptions are fulfilled, both the assumptions, I mean, the assumption of homogeneity of variance and the assumption of normality, both the assumptions are fulfilled, we have to apply one-way ANOVA. Is it okay?
Yes, sir.
And we can extend the study or we may not extend the study. If the significant difference exists, apply post hoc test, otherwise study ends. Is it okay? Condition number 2, point number 2, please write down. Point number 2, condition number 2. If the assumption of normality is not fulfilled,
Yes, sir.
there is no need to test the homogeneity of variance.
Okay.
There is no need to test the second assumption. And the second assumption is
Homogeneity of variance.
to apply parallel non-parametric technique, Kroskal-Wallis test. Kroskal-Wallis test. Is it okay?
Yes.
We have discussed when to apply one-way ANOVA and when to apply Kroskal-Wallis test. We have discussed that if the assumption of both assumptions are fulfilled, apply one-way ANOVA. If the assumption of normality is not fulfilled, there is no need to test another assumption, apply parallel non-parametric technique. Condition number 3. Situation 3. Situation
3.
Madam, in the first situation, if both the assumptions are fulfilled, then we applied.
One-way ANOVA.
If the condition of situation number 3, if the condition of normality is fulfilled, but the condition of homogeneity of variance is not fulfilled, so we cannot apply one-way ANOVA or
Kroskal-Wallis
test. We have to apply a third technique. And the third technique is either, we have options here, either apply Brown-Forsythe test or Welch test. Brown-Forsythe test or Welch test. So I am going to demonstrate how to apply Brown-Forsythe or Welch test. Madam, where is my cursor?
Analyze.
Then
Compare means
now
it's a one-way ANOVA.
and now see two techniques, Brown-Forsythe test and Welch test. Either apply this or apply this. I am going to apply both. We require one. Both Brown-Forsythe test and Welch test. Both fulfills the same purpose. Is it okay?
Okay, sir.
Both fulfills the same purpose. Continue. Click on OK. The result of Brown-Forsythe and Welch test will be in front of you. See the result of Welch test. It is also insignificant. The obtained significance value is 0.832, and for Brown-Forsythe, the value is 0.830. More or less, the value is same. Both tests, this Welch and Brown-Forsythe, fulfills the same objective. Is it okay?
Yes, sir.
Now the story ends from my side. The story of one analysis of variance, not analysis of variance. We have discussed about the story of comparing more than two means. Now we will discuss again. If you have doubt after my explanation, you can ask your questions. Ladies and gentlemen, we have discussed about the story of comparing more than two means. To compare two means, we have to test the assumptions. Let's start with the first technique, that is one-way ANOVA. One-way ANOVA is used to compare more than two groups. This technique can be applied with equal sample size, with unequal sample size. To apply ANOVA, two assumptions should be fulfilled: the assumption of the normality and the assumption of homogeneity of variance. If both the assumptions are fulfilled, we have to apply one-way ANOVA. And to test the assumption of the homogeneity of variance, we have to calculate the value of 11A test. If the assumption of normality is not fulfilled, condition number 2, in that case, we are not supposed to test the second assumption, directly apply parallel non-parametric technique of one-way ANOVA, that is known as Kroskal-Wallis test. If in the condition number 3, if the condition of normality is fulfilled, but the condition of homogeneity of variance is not fulfilled, in that case, we have to apply either Brown-Forsyth test and Welch test. Again, come to the first situation, application of one-way ANOVA. If we applied one-way ANOVA, if the insignificant difference exists, the study ends. If the significant difference exists, we have to apply post hoc tests to compare paired means. For equal sample size, we have to apply LSD, least significant difference post hoc test. And for unequal sample size, we have to apply Scafe's post hoc test. Now come to situation number 2. In situation number 2, we applied Cross-Cornwallis test. Same will be applicable here. If insignificant difference exists, the study ends. If the significant difference exists, we have to extend the study to compare paired means. There is no option of post hoc test. We have to apply the parallel non-parametric technique of independent t-test that is known as Mann-Whitney test. We have to compare paired means by using Mann-Whitney test one by one. Come to the condition number 3. If the assumption is not fulfilled of homogeneity of variance, we have to apply Brown-Forsyth or Welch. Ladies and gentlemen, one main point, the post hoc option will be same as one-way ANOVA in Brown-Forsyth and Welch test. Now the story ends from my side. You can ask any type of question. We have discussed in detail about the application of comparing more than 2 means. Please ask questions. If you have doubt, you can ask questions.
Sir, for homogeneity of variance for Levin significance, the p-value, what should we consider? P-value more?
Madam, I am asking a cross question from you.
Okay, sir.
If in any technique, not in homogeneity of variance, in any technique, if the value is less than 0.05,
it is significant.
it is significant. If the value is higher than 0.05,
it's not significant.
In case of homogeneity of variance means all the groups should be equal. All the groups should be equal means.
So p-value should be greater
there should
than
not
0.
be any significant difference.
Yes.
It
Okay.
means the value should be
More than 0.0.
Yes, madam, it's clear.
Yes. Thank you, sir.
You can clear your doubts if you have, otherwise permit me to leave.
So other participants, you don't have any doubts?
I hope there is no need to study any literature about the application of one-way ANOVA. There is nothing more than this in case of comparing more than 2 means. There is nothing more than this. So we will discuss one by one all techniques. We will discuss one by one. Today we have discussed about one-way ANOVA. We have discussed about Cross-Cornwallis test. We have discussed about Mann-Whitney test. We have discussed about Brown-Forsyth test. We have discussed about Welch test. We have discussed about the application of post hoc test, LSD test, Scafe's test. About several techniques we have discussed.